How bizarre is this? Have you ever seen something like this before? This material is rather strange. It's called ferrofluid, also known as magnetic liquid. Not many liquids do this, and this is because this liquid has got tiny nanoparticles, magnetite, in it. This is Materials Lab, and today we will discuss ferrofluids. Ferrofluid is a liquid that becomes highly magnetized in the presence of a magnetic field. This spiky-looking shape is caused by the need to find the most stable shape in order to minimize the total energy of the system, an effect known as normal field instability. The fluid is more easily magnetized than the surrounding air, so it is drawn out along the magnetic field lines, resulting in the formation of peaks and troughs. However, the extension of the ferrofluid is resisted by gravity and surface tension. Ferrofluid was created by Steve Papel of NASA in 1963 for use as rocket fuel. The ferrofluid was mixed with liquid fuel and drawn towards the ignition systems with an external magnetic field.
Ferrofluid is simply these suspended nanoscale particles in a carrier fluid, such as an organic solvent or water. These nanoscale particles are usually iron compounds, such as magnetite or hematite. It's actually the same iron that you can find in beach sand.
Ferrofluids have now found use in many applications, from small electronic devices to spacecrafts to cancer treatments to art. It's quite possible that you have some ferrofluids in your house right now. You can find them in hard drives, where they are used to seal the interior of the device. When magnetized, they form a barrier to dust and dirt, which could damage the delicate plates. Ferrofluids can have very high thermal conductivities, and their heat transfer properties are exploited in devices such as loudspeakers, where they are used to cool the voice coil. In a loudspeaker, the sound is produced when the voice coil vibrates, but this also generates unwanted heat. And ferrofluid will absorb heat around the voice coil and then be moved towards a heat sink as it is replaced by a cooler ferrofluid. As ferrofluids are visually different from the majority of other materials, they became an interest for artists. Nikola Illich came across an online video of moving ferrofluid sculptures by Japanese artist Sahiko Kodama, with black liquid rising into swirling bristles that joined into quivering spikes. The artist-entrepreneur immediately wanted a ferrofluid display for his desk. A few years later, he created a company that sells ferrofluid in glass jars for those who are interested in seeing how it practically works. There are many scientists developing new ideas and uses for ferrofluids that will exist before the end of our lifetime. For example, a team at the Harbin Institute of Technology in Harbin, China, published a study showcasing liquid micro-robots made from ferrofluid droplets. Their droplet robotics are oil-based because they envisage applications in the watery fluids of the body with which the droplets do not mix. It's clear that there are many possibilities for ferrofluids, and it's only a matter of time before they are discovered. Graphene is an amazing material, yet it was only discovered in 2004. This is the thinnest light bulb, and it's made from graphene. This is Materials Lab, and is graphene a wonder material?
Graphene is my best bet for the next disruptive technology.
Graphene is a single thin layer of graphite, the soft flaky material used in pencil lead. A diamond and graphite are forms of carbon, yet they have widely different natures. Diamonds are incredibly strong, while graphite is brittle. Graphene's atoms are arranged in a hexagonal arrangement. So, when graphene is isolated from graphite, it takes on some miraculous properties. It is a mere one atom thick, the first two-dimensional material ever discovered. Graphene was discovered by André Game and his students. Game set Dajiang the task of obtaining as thin a sample as possible by polishing a 1-inch graphite crystal. During research, Game and a PhD student named Konstantin Novoselov discovered that graphene had a pronounced field effect, the response that some materials show when placed near an electric field. This would then go on to earn Game and Novoselov a Nobel Prize in Physics in 2010.
This prize so very special. From the very bottom of my heart. Thank you all.
Silicon is defined by its ability to field effect, and many researchers believe that graphene could replace silicon because of this.
We have developed full technology of a graphene-based magnetic field sensor. This sensor were produced of graphene on silicon carbide.
Research into graphene was ignited, and scientists across the world were startled by their findings.
We started to see it first in composite material applications, in sport goods. Now it goes into advanced cars, but now we already start to see it being used for electronics, for printed electronics.
It is one of the thinnest materials known to man, yet it was 150 times stronger than an equivalent weight of steel. It is as pliable as rubber and could stretch to 120% of its length. Unfortunately, it does come with some negatives. For example, graphene cannot be turned off. A device that cannot be turned off consumes way too much power. The electrons go super fast thanks to graphene, but it can't be turned off. Some scientists believe that the real issue is business. Silicon is the go-to material for semiconductor chips, and the industry is based around this. For graphene to become the norm, then it first needs to work with silicon in existing production lines. Outside of semiconductor use, graphene has been used in bulletproof vests that had twice the stopping power of a Kevlar vest, or 10 times better than a steel plate. Batteries were capable of charging to full in 5 seconds. Researchers have developed graphene-enabled electrochromic glass that can switch between solar heating and radiative cooling modes. Our device has one of the largest tuning ranges in thermal radiation ever demonstrated, Po Chun Snu, materials scientist, Duke University. Graphene has been found in the concrete industry. Scientists at the University of Exeter developed a new method to add the material to conventional concrete.
We learned here at Exeter recently how to combine the lightness and the stiffness of graphene into an ordinary material like concrete to make a new form of concrete that goes under the name of concrete. And that's what we are talking about. We have a new kind of concrete that is lighter and stiffer than normal concrete.
The technique is to add water-stabilized graphene dispersions to a concrete mix, resulting in a material with double the strength and 4 times the water resistance. Even though graphene is being researched in multiple areas, its cost is still high. The price of graphene can range anywhere from $100 to $450,000 per pound. This, of course, depends on the quality. Unfortunately, not all graphene is created equal. You can, of course, have lesser quality for cheap, but the best is required for the advancements we seek. In the future, graphene could become the wonder material that many scientists believe it has the potential to be. We will just have to wait and see what happens.